All right, welcome to video 4, the fourth video for your Unit 5 Covalent Bond Study Guide. So we're going to be looking at starting at number 13. We just got done doing number 12 on page 3 on the last video. So it says, based on your observations from the data of this experience, do you predict that pentane will have a stronger or weaker intermolecular forces than hexane? So that's where we're then going to need to look back to that data table. So here we have the data table. Please notice we've got pentane right here, we got hexane, we got octane. As mentioned in class today, and also yesterday for A-Day folks, as you notice, the lighter or the heavier the molecule is, the weaker it is. That smaller that your change in temperature is going to be. So as we have pentane is, we have data for our hexane. So hexane has a molecular weight of 86.17. Pentane has a molecular weight of 72.15. So it is a lighter molecule. So if it is a lighter molecule, hence these ones as well, lighter molecules will be weaker. So here we have, based on the observation, so pentane will have weaker intermolecular forces than hexane. So then here we have predicting of octane having stronger or weaker. Looking back to the data table as well, we've got pentane, we've got hexane, we've got octane. Please notice molecular weight is going to be lighter for pentane than it is for hexane, but then octane is significantly more heavy than hexane, so then that one would be stronger. So here is your final thing for a level 3 on your learning target. So level 3 is saying that you can predict the properties of a molecule, excuse me. Your long-term learning target is I can predict properties of a substance based on its molecular structure and support these predictions with experimental data. Here we go. Here's some experimental data and making some predictions. So we've got pentane and we've got octane. So now we need to predict our delta T. So note on the assessment, there will be also here, this right here, this part will be blocked off. So you won't be too confused. So I'm going to just block that off right now. So you got pentane and octane. Pentane, so as the same similar situation, as you increase in your molecular weight, you're decreasing in your delta T, your change in temperature. So your change in temperature for pentane would be something that is larger than 22.07, and your change in temperature for octane will be something that's lower than 22.7. So your trend is you're decreasing as you're going down there. So anything in this point that is going to be, again, your delta T for pentane is going to be larger than 22.07. So I could do 22.08, I could do 22.70, I could do 29, as long as it is larger than 22.07. And then delta T of octane, we mentioned that the delta T, as you get bigger than hexane, your delta T would be something that is then smaller than 22.07. So that could be 22.06, that could be 21.42, that could be 19, as long as it is less than 22.07. And then now we get into the level 4. So the level 4 is you can analyze multiple sources of experimental data to determine the identity of unknown substances. So you've got substance A and you've got substance B. So it says, during the lab, substance A and substance B were found without labels in the lab. After conducting the same experiment as above or on the previous page, the properties were determined. Using the data below and possible substances, determine the identity of each and describe your reasoning. So we have substance A has hydrogen bonding. The delta T is 1.89. So we're going to, the possible substances that are provided here are going to be methane with a molecular weight of 16.4, pentanol, 88.15, pentane, 72.15, heptanol, 116.20, and nonane, which is 128.25. So here we have a delta T. It does have hydrogen bonding. If it does have hydrogen bonding, the only two possible substances are going to be anytime we have a hydrogen bonded to an oxygen, nitrogen, or fluorine. remembering that that's going to be these three atoms on the periodic table. So anytime we have a hydrogen bonded to a nitrogen, oxygen, or fluorine. In this case, we do have we have two molecules that are have a hydrogen attached to an oxygen, and that's pentanol and heptanol. So we're going to need to figure out where is this 1.89 going to fit onto our graph. Got 1.89, 1.89. So 1.89 on our change in temperature on here is going to fit somewhere here. And then that number of our molecular weight is going to fit somewhere. So 88.15. 88.15 was what it was for pentanol. Please notice. And then we've got heptanol, which is 116.2. 116.2. So that both. So in this case, substance A can be anything. It can be either anything that it has hydrogen bonding. It could be pentanol or heptanol, because both have hydrogen bonding. Excuse me. The molecular weight is larger than butanol, and the delta T is smaller than butanol. All right, so there would be letter A for, so you need to be able to answer 17A and B for a 3.5, 17A, B, and 18A and B for a 4. So substance B, so here we have substance B. Substance B would say that there's no hydrogen bonding, and we've got a delta T of 23.32. So our choices for something that does not have hydrogen bonding would be methane, pentane, and nonane. None of those have hydrogen bonding, so we've got one that has a molecular weight of 16.04. We've got one that has 72.15. We got another one that has 128.25. So we've got 23.32 is our delta T. So we're going to then need to, again, look for our delta T. So our delta T, that would then need to be able to fit here. So our delta T would be something that would be in this range. It needs to be then less than hexane. So any of the molecules that are less than hexane are going to be either that methane or that pentane. It cannot actually be the nonane. So the nonane has a larger molecular weight than hexane. If we were to look at those, so 128.25. 128.25 would be down here, so therefore then it would have to be less than 22.07, and the delta T that we have is going to be 23.32. So substance B can be either, again, also either of these things. Substance B is most likely methane or pentane, because both don't have H bonding. The molecular weight, I'm just going to write MW for molecular weight, is smaller than hexane, and the delta T is larger than hexane. All right, so there's 17A and B. So then it's asking, from these possible substances, which of the possible substances are polar? How do you know? So here are our possible substances. So which ones are polar? So we've got these ones. As a reminder, polar means that there is an imbalance of, that is not a symmetrical atom. That means there's a pull on most sides. So the two substances in this case are going to be the ones that have hydrogen bonding. So the two possible substances are pentanol or heptanol, How do I know? Is because they have hydrogen bonding, which causes unequal electron distribution or sharing, or unequal electron sharing in the molecule. Excuse me. All right, then which ones are nonpolar? The ones that are nonpolar are going to be the ones that are not the two that we just chose. So we've got methane, pentane, and nonane. So then we've got methane, pentane, and nonane. They are non-polar because they do not have hydrogen bonding, but more likely, so they have a balance or equal sharing of electrons in the molecule, and the intermolecular forces are weaker. All right, so there you go. There you have it, all 4 pages. Hopefully that was helpful, and please let me know if you have any questions about any of this assessment or any of this study guide. You're absolutely welcome to give me a message on the Remind. Another bell for you. Remind, contact me there. Contact me on the Remind. Or you can also email me at mday@pps.net. This is the best way, because then that comes to my phone, that comes to my text. So if you don't have the Remind, the best thing to do is to first email me, and I can at least get you registered for that. All right, have a great weekend, and hopefully you enjoy studying. Take care. Bye.